Hello and welcome to this August edition of the IoTSF Security Foundation monthly webinar series. My name is 𝗂𝗲𝗰𝘂𝗿𝗁 and thank you for joining us today. We'll give it a few moments to allow people to arrive from wherever they are in the world. As you know, we have an international audience, so they can be a little bit late. So we'll just wait for them. But whilst we wait for a minute or two, I want to tell you about two events coming up very soon. The first event is a meetup by IoTSF Amsterdam. This will be their first in-person event after launching last month, as you know. The meetup will take place in The Hague at the IoT Security Delta today at 5:30 Central European Summertime, and will feature a talk by Jan Jaeger. The topic will be how to test firmware for fault injection vulnerabilities. It will explore the threat of fault injection for firmware. There'll be a Q&A, refreshments. If you are watching live, the link is just appeared in the Zoom chat facility there by my colleague Chris. So if you are by any chance in Texas, IoTSF Houston are having a meetup on Thursday, the 26th of September at Second Draft on Main Street. It's going to feature a talk from Chris Wolski, and his topic will be navigating the future, the impacts of IoT on the maritime transportation industry. The Houston meetup is sponsored by esteemed IoTSF member Komodo, and there'll be drinks, snacks, networking. Again, if you're watching live, we've just put in a link to the Zoom chat facility so you can register for that. So coming up, we'll have Vaidi and Ram of IoTSF Chennai, who will be showing us around the fascinating Smart City Lab. It's one not to miss, honestly. We've seen it just as a preview version in the last few days, and it's fascinating. So stay tuned for that. But first, our guest today is from the IoTSF, is an IoTSF member, BT, 𝗬𝗲𝗏𝗂𝗏, who is a research manager and security consultant from BT Research and Network Strategy. His presentation today is entitled IPV6 and IoT Security Considerations for Engineers and Solution Designers. So if you have any questions, comments, or observations for Sam, put them in the Zoom chat and we'll ask them later in the Q&A section. But now, Sam, the floor is yours.
Thank you very much, 𝗂𝗲𝗏. Let me just share my slides for everybody. Let me know if they come through in a second. There we are. Is that coming through okay, 𝗂𝗏𝗏?
Yeah, we can see it.
Wonderful. So good afternoon, good morning, good evening to you, wherever you are. Thank you for your interest. I'm 𝗬𝗏𝗏𝗏𝗏. I'm a security consultant at BT Group. We're a multinational telecoms provider who focus on interconnectivity of people, devices, and machines. So today I'm going to cover something that's a bit of personal interest to me. It's IPv6, a technology that you've no doubt heard about, but you may be considering as something which has never really caught traction or grown in the world of technology. Well, I'm hopefully going to try and steer you a little bit today to why IPv6 is something you should be considering as part of your deployments in IoT, and also some fundamental thinking about how to operate with it differently to v4 and how you should approach it going forward. But first, we need to do a small history lesson. So everyone's familiar with this structure of addresses. This is an IPv4 address. Essentially, you've got 32 bits, ones and zeros in a long line. You can pull a one-armed bandit, the famous gambling machine, and no matter how the ones and zeros land for different IP addresses, you only ever get 4.3 billion of those addresses. IPv4 is old. It's from 1981. The technology was born of a time when you weren't connecting people to one another, you were connecting businesses, campuses, and offices. So 4.3 billion was considered to be enough and was slightly limited by the computation power of the day. This is 32-bit numbers in the 16-bit CPU days. But some smart folks at the Internet Engineering Task Force realized very quickly that if the futurology vision is for everyone to have a device in their pocket and everyone can reach each other across the internet as it was growing, then this is a bit of a problem because we already have 5.5 billion people on the planet in 1992 alone. So the IP exhaustion problem was described. And then engineers did something interesting. Rather than try and immediately create a solution that solved the address space problem, we got something called classless interdomain routing and private address space. And for the network engineers on the call, those numbers at the bottom are no doubt familiar. Essentially, a little hack was done where we have the idea of you have your public address for a business, and all the devices behind the business's edge router or network can have their own addresses. And we will simply swap between the public and the private. And that's a way the internet has worked for time immemorial. The way of that working is called network address translation, NAT, and between September 93 and May 94, these two technologies were abridged to create the internet flow as we know it today. But we're out of IPv4 addresses now. They are all gone. In fact, 13 years ago, the last /8 IPv4 block was allocated, so they're gone. Everybody owns one or has a stake to them, and it's important to remember that network address translation and classless interdomain routing are workarounds, almost hacks, it could be fair to describe them as, to handle the IPv4 exhaustion problem, but adding complexity and opportunities for mistakes and issues when the original vision for the internet was device-to-device connectivity rather than device-to-router translation to device. More bumps in the road, if you like. So then switching tack to IPv6, what is it compared to v4? Well, I mentioned before that IPv4 has 32 bits in the address space, 4.3 billion addresses. IPv6 cranked it up to 128 bits for the address space. That gives you the number on the screen, which I cannot begin to say. I've done some research on this, and there's enough IPv6 addresses for every atom on the surface of the Earth, every grain of sand, every molecule of water and the atoms within, and then enough to do that 100 times over. So we have 100 Earths worth of IPv6 address space to play with. Hopefully you're enjoying the snazzy logo on the screen showing that IPv6 is not new. It's from 1996, and the logo there shows its age. Also, the logo to the left of it, IPv6 launch day in 2012, the push by industry for adoption by v6, which didn't seem to quite gain the momentum that they were hoping for. It's completely different to IPv4, and a lot of folks who try to adopt IPv6 or even to experiment it often get frustrated early on when they don't understand why their prior knowledge and experience in the world of v4 that they've grown up in is translatable to IPv6. They say, why doesn't this work? Why is it this way? Why is it different? Approaching v6 as a topic is easier, I've found, as someone who's learned it recently, if you come at it with a completely fresh mentality and a fresh mind. Most of IPv4's working does not translate to v6. And the joy of v6 is with a massive address space, we get globally routable addresses for all. So everyone, every device can have millions of IPs allocated to it. There's no problem. And on the screen, there are some examples of IPv6 addresses in comparison to the ones I showed previously, which were v4. You'll notice that we can use letters now, and the address itself is much longer, so we can make words and we can play around with these to our heart's content. And it's a huge pool, vast pool to deal with. There are many other technical benefits to IPv6, some of them relating to performance, some to security, which I won't cover in this talk. I only have 15 minutes left already. And I could perhaps do a follow-up for those that are interested, but it does have other advantages. But importantly, it solves the address space problem, it solves the NAT problem, and it, interestingly, if you're a IoT solution deployer, solves a money problem. Because all the IPv4 addresses have been allocated, there's sort of a stock market for what are left of the IPv4 blocks when people want to put them up for sale. 1,000 IPv4 addresses in the public domain goes for about $28,000, which if you're a startup trying to get into an IoT solution space is extremely unappealing. IPv6 is effectively free by comparison. As I mentioned before, it's effectively limitless. So you're not bound by tightly controlled subnets with limited ranges and having to handle complex routing rules between domains. One standard /64 subnet in IPv6, which is the smallest subnet you can have, has 18 quintillion addresses in it. BT broadband customers are given a what's called a /56 prefix, which means they actually have 256 times 18 quintillion addresses they could use in their own homes if they wanted to. Obviously, these are fanciful numbers, but the importance of the scale is it works well with things like futurology visions for smart city, sensors in every paving slab, traffic lights, billboards, moisture sensors, everything you can think of, interconnected vehicles. This is where IPv6 belongs, and this is what it was dreamt up for. Important to note that although everything is globally routable, that does not necessarily mean it's reachable. One of the first reactions people have to the topic of V6 is, if everything's on the internet, surely that's a security problem. No, just because it can be routed to over the internet does not mean, if firewalling and conventional security practices are followed correctly, that it is reachable. It's an important distinction to make. There's no more NAT, no carrier grade NAT, which is the term used for when you take a very vast private IPv4 address space and then plug it back into the public internet by doing huge complex manipulations of network address translation. Mobile phone networks are an example where carrier grade NAT is used. We don't have to do any of that anymore. The complexity is removed, and there's also no hairpin NAT. That's the expression used where if you have a website or a service you're trying to build and you're sitting inside that domain when you're working on it, we are trying to view it from the exterior as if you're a customer. You have to put complicated firewall and routing rules in to simulate you're coming from external. All gone. Easier configuration and rollout. A huge boon if you're into building solutions for IoT. We also have something called stateless address auto configuration, or SLAC. One of the benefits of IPv6, you can essentially connect devices to Wi-Fi or Ethernet, and they can auto provision themselves and learn from their neighbors what the existing configuration of the network is, which is another huge advantage over IPv4. Also, you can quickly change the gateway, DNS, the prefix used for all of those devices, effectively the front part of the address in the global network. All of this can be achieved quickly and easily through something called router advertisement. So it's very powerful when dealing with devices or widgets at scale. Then the topic I've mentioned a minute ago, actually, the idea of anyone can reach my device from the internet. Bad. Well, no, not necessarily. If everything is reachable from the internet, that can help do away with some things like point-to-point VPNs for remote device management, having to deal with complex reverse port forwarding rules, and how do you reach your IoT devices when they're hidden behind some other network element in IPv4? All of that's removed. But as I mentioned before, routable does not mean reachable. With appropriate firewalling and other systems in place, conventional systems that people are not having to learn from the ground up, you can do IPv6 very easily and securely, and not have to worry about leaving. Well, you should always worry about leaving ports open on your devices, but in addition to that, you can put a firewall in front of it quite easily. And a moniker I learned, or an expression I should say, I learned early on working in V6 is that network address translation never stops cybersecurity breaches. I can't think of a single publicized incident where NAT was the savior or would have been a savior to a breach. So use your firewalls. There's a little element of security through obscurity in IPv6 because the pool is so vast. It is essential this pool and how it gives a slight security through obscurity factor. Because the address pool is so large in IPv6, it's effectively unscannable. So conventional port scanning to find vulnerabilities in IoT systems and platform, it's never going to happen. A single IPv6 subnet will take 2,000 years plus to scan, even with a gigabit connection. So there's a slight factor of security through obscurity involved, though it's not something to live by. One of the issues, though, with V6 is you still often have to run with V4 in parallel. Challenge there is it means twice the workload for your staff, your engineers, and from a security perspective means you've got twice the opportunity to make mistakes with your rule sets, routing, and so on and so forth. Bear with me. Just make sure the slide deck's there. So that comes to the root point of validating your infrastructure when doing IPv6, but doing it with trained, experienced, and preferably qualified staff, firewalls, routing, and VLANs. A curiosity about IPv6 is it actually requires some open ports on a firewall for it to work properly. That's part of how it works. It uses ICMP-v6 to negotiate packet and window sizes and things like that between two endpoints across a network. So some ports confusingly need to be open for v6 to work correctly. More opportunities to make mistakes if you're not quite sure what you're doing. And I'm just highlighting there on the bottom that the layer 8 problem in the stack, the people problem, is much more strong than usual, especially with double the stack, double the workload, double the opportunity for mistakes. But that brings me nicely to the idea of staff education and the massive skills gap that there is in the industry. So the diagram on the right-hand side is a popular metric for us IPv6 fanboys. It's the amount of traffic and polling that reaches Google's query systems and servers. In the UK, we're now at about 50%. We're actually quite behind on the global scene. In places like Germany, for example, IPv6 adoption is at 80%. So much higher than the UK. But that means that, for example, us, BT, as a carrier and provider, we're pushing terabits of IPv6 traffic every single day. So the engineering resources are needed, the expertise is needed, and training is needed, and there is a deficiency in the market because of the lack of interest in the topic. The biggest problem is the lack of education and awareness that v6 even exists. And for those that are already in the industry and have been for a long time, there is apathy towards the topic because, oh, v4 has worked, v4 will work, therefore why should I bother to learn v6 is the #1 problem. The second problem is system administrators must often actively enable IPv6 in their infrastructure. That's the routers, the firewalls, web servers, email servers, DNS records, you name it. On clients, so your phone, your laptop, your PC, your Xbox, whatever it is, that prefers IPv6 by default. But at the other end, in the implementation, engineers have to proactively do it. Therefore, C.1, lack of education and awareness. And some folks who work in network engineering argue that IPv6 is too complex, too difficult to deploy, especially as an enterprise, which is not true. It's not difficult, it's just different. C.2, C.1. The world is moving on. Whether you want to be a part of it or not is irrelevant. IPv6 engineering roles are growing. I actually posted at the very bottom of the screen there a role that BT is currently advertising for, Senior Manager, IP Address Strategy, with a specific focus on IPv6 transitioning, because we want to go fully native IPv6. Many of the smaller ISPs in the UK actually favor v6 because it's cheap to acquire, cheap to roll out, and you don't want to go burning your startup Series A, Series B funding on acquiring IP addresses when you don't need to. So it's often a required skill set in newer roles. The good news, however, is that there are vast troves of training resources. v6 has been a challenge to learn and acclimatize to if you're familiar with v4. So there's huge amounts of resources on YouTube. Amazon in particular have a very good treasure trove of IPv6 resources. I've done a screenshot of their IPv6 on AWS white paper on the right there. They're big proponents and supporters. Many of their engineers enjoy using v6 and they've passed that enjoyment effectively onto their customers. Adoption's growing immensely. So you'll be in friendly company in the industry as we begin transitioning to this new paradigm. And the best thing about v6 is it doesn't cost anything. It's a standard. It's on every laptop, it's on every phone, every router, every switch. It just needs to be turned on. It's free to learn with and it's free to experiment with and make the mistakes and the learning in your own time, in your test or build infrastructure, or ever going near production. So what should you be doing? This is my closing slide. A takeaway from my little talk. What I'd like you to take away, in effect, as a solution designer or an engineer, look forward to v6 as a way of future-proofing and scaling IoT solutions. That's one of its best assets and what you should be keeping in the back of your mind when designing solutions. Mandate vendor support for v6. So if you're using network infrastructure, verify and validate and mandate that they support IPv6, not only to ensure that they are decent quality, but to future-proof your platforms and everything you've been building hard for the last few years or will be building. If you're buying in from someone, validate it. If you're building something yourself, some little ESP32 widget that's going to go into a traffic light, validate it has a V6 stack. And if you're building it yourself, make sure it's in there. Prioritize recruitment of staff who have demonstrable V6 experience, or encourage, train, and I should have put on here, reward V6 experimentation, learning, and development, and allow people to experiment. And the best way I find anyway to learn is through experimentation. Find out why it doesn't work and find out then how to make it work. And last but not least, require V6 hosting from your providers. IPv6 needs a end-to-end connection, so it doesn't matter if you've got V6 running, but your ISP isn't prepared to deliver it, it's a pointless conversation. So make sure that your internet service provider, your peering partner, supports IPv6 interconnectivity, and BT, of course, we do. It's a little shout out to ourselves there. And with that, that should bring me to the end of the slide. Thank you for your attention. Thank you for your interest. And I think we now go to questions if I pass back to Palm. So thank you.
Thank you, Sam. That was great. And yeah, it was really nice of you to finish off that presentation. So thanks for doing that. It was really good. Sam's, sorry, just going to put my video on. Sam's LinkedIn is available in the chat as well, in case you want to get in touch with him, if you have any questions. So please feel free to get in touch with Sam. And the same with Vaidya and Ram as well. Their LinkedIn profiles, company profiles are in the chat. So if you have any questions, please do get in touch with them. It'll be good to talk about the IoTSF annual conference taking place at the IoT on Wednesday, the 23rd of October. We'll have 10 contemporary and advanced sessions with themes of security, including AI, advancing security practice, security by design, the CISO journey, mastering the economics, regulation and compliance, and memory safety. We'll also have international speakers all the way from the USA, Europe, and Australia. So an early bird ticket price for non-IoTSF members ends on Monday, this Monday coming up, which is on the 2nd of September. So move fast if you want to save a bit of money and purchase that ticket. So limited sponsorship and exhibitors opportunities are still available if you move quickly, and all details surrounding the conference will be available in the Zoom chat, which my colleague Chris will be putting into the Zoom chat for you to click onto.